Hello. Here is an introduction to annual daylighting performance in a spreadsheet that you can use with scale model tests. So for your daylighting design team project, you'll be wanting to use this. There'll be some reminders here about how to use the spreadsheet and a general introduction to what it does, the usual input screen, and one of the things that's produced is a section isolume of your design. So this says for the percentage of time how many foot candles will be maintained at different locations in the space. To explain, well, if we enter our latitude, the glazing visible light transmission, and the correction factors for dirt accumulation, which you can get in your textbook from table 14.5. This also simulates very directly figure 14.27, which lets us estimate for a given latitude about how many foot candles of daylight illumination are available, what percentage of the year during daylight hours. So, with those factors in mind, we'll go into the artificial sky and we will measure, or one can target if you wanted to use this in a planning rather than an experimental way. But if we did go into the artificial sky, we can measure the percentage of light that's received at some point inside the model as a ratio of how much light is available outside. That's called the daylight factor, right? Received divided by available. So there's usually quite a bit of daylight outside, and generally in a space we don't expect to get more than 2 to maybe 10% of that, but very close to the window we'll get a lot more. So when we measure in our space the daylight factor at various positions, right, we can record that percentage for those different positions. And here I've entered those hypothetically as if this was very close to the window and increasingly far away, but your circumstance might be different. You might have special places that you wanted to measure rather than a scale of distance from the window. So you're going to do 3 tests. First, well, in any order, one test is to measure photorealistically with the interior of the model and the foreground of the model replicating the reflectances of the real world building. Then we'll, in another test, and again in any order, cover the foreground with black to eliminate external reflections. And then in the third test, have both a black ceiling and a black foreground to eliminate internal and external reflections. So by subtraction, the spreadsheet goes in and subtracts from these values that you measured separately to tell you what percentage of the light is direct from the sky, what percentage of it received at this position A comes from the external reflections, and what percent of it is bounced around the room internal reflection wise until it comes to the task. So for each of these positions, by testing it 3 different ways, you'll be able to segregate how daylight gets to that point. Then the spreadsheet, by knowing your latitude and the daylight factor, the glazing ratio and the dirt correction or the environmental correction, can look at how many foot candles would typically be available at that latitude for some percentage of the year. These are percentages of the year, and forecast for you how much light to expect from daylight during the hours 9 a.m. to 4 p.m. at these positions at the task surface where you measured your daylight factor. And then finally, to depict that for the task positions, the percentage of time illumination levels will be exceeded, and here you see those illumination levels. That's all for daylighting performance.